We're going?
Yep.
Okay, so as we were talking about, the subnet mask tells you what part of an IP address is the network address and which part of the IP address is the host address. Okay? You determine as a network administrator what the subnet mask is. You determine what that is. Now there are some standards, there are some rules, there are some defaults, right? What's a default? What's a default? What is the default?
Default?
Yeah, what's the word default mean? We use it a lot in the computer world. Like the default setting.
Just like the general setting.
The normal setting, right? The default, you can change from that, you can make it different, but the default is this. And we'll talk about some of the default subnet masks here in a little bit. Guys, it's very, very important for you to focus and try. This isn't just, if I sit here and I listen to them, I should get back. No, you have to think to be able to get through this. You will fail miserably if you don't. You have to think and try to understand and memorize. Okay, again, this is more the same. In order for an IP address to function, it must be a properly configured IP address and compatible subnet mask. Disregard the next one a little bit later, until a little bit later. Okay, IP4 classification is known as the classical network architecture. Don't get wrapped up around that, other than to know that you're going to have some memorization here. There's a chart in the book that you'll need to take a look at. There are multiple classes of networks, a Class A network, a Class B network, a Class C network. And then beyond that, we have some unique ones that we'll talk about. But here's the thing to know. Remember I said there are some default subnet masks? In a Class A network, the default subnet mask is 255.0.0.0. One thing that they introduce in this slide that we haven't talked about yet in this chapter, but we've talked about it before. What is an octet? Yes?
The numbers inside of the dots, like 255 would be an octet.
No, 25, it represents an octet if, Seth, get your hand up.
It's the dots and the numbers.
It's that portion, but an octet represents something else. Yes?
All right, so that 255 is a partial of the 8. There's 8 of them. Like,
No, you may be you're along the right track. Okay, so the 255 is in, or the 192, or the 208, or the 176 is in what format?
Decimal.
Decimal format. Okay, if there's a decimal format, I'm bringing it up for a reason. The computer converts that 255 to a what format?
Binary.
Binary format. In binary format, it's all ones and zeros. Okay, in binary format, that first portion of the IP address in binary format is made up of 8 characters, an octet. If I convert 255 to binary format, so in other words, I'm going from decimal format to binary format, does anyone know what that number is? It's 8 characters, 8 characters. It could be 1 0 0 0 0 0 1 0 1 1 1 1, you know, up to 8. But 255 represents what binary number? Yes.
is it 1 1 1 1 1?
I didn't count how many, but it's 8 ones.
8
8 ones. 8 bits. 8 bits makes a byte. A bit is a single character, a 1 or a 0. 8 bits. Austin?
Is it now, I don't know if this is a typo, but it says the classical network is supposed to be classical.
Classical network, what is what now?
In the second line, it says the classical network. Is that a typo, or is that a?
No, classical is
Classical network architecture.
classical network architecture. No, that's actually what it represents. As in classless. We'll talk about that a little bit later. Question?
Yeah, you said bits make bytes.
Yes, 8 bits make a byte. But don't worry about that for here, okay? 8 bits make a byte when we're calculating numbers and such. Okay, let's back up. Each one of those sections, if I convert each one of those sections, each one of them is 8 binary numbers or 8 bits, right? So the 208, if we convert it to binary format, there's still 8 characters. There are 8 bits in that. So if we add up the number of bits in the entire IP address, how many bits are there? Yes?
32.
32. 4 times 8. There are 32 bits. Okay? So there are 32 bits in that IP address. 4 octets. 4 octets. OCT being 8. Yes?
So like 208 automatically converts its binary format.
The computer will do that for you, yes. Okay, but we don't use binary format because it's too long. 32 bits, trying to memorize that is almost impossible. Trying to memorize 208.32.56.232 is not all that easy, but it's easier than trying to memorize the right placement of ones and zeros, because the placement of those ones and zeros means everything. If I have 7 ones and 1 0 at the end versus 1 0 and 7 ones, those are 2 vastly different numbers, and I'll show you what those are here in just a little bit. Not a little bit, yeah. Yes?
So computer version 2 octet is 32 bytes?
No. 32, an octet is 8 bits.
Well, I mean, sorry, the 4 octets I got put together.
4 octets is 32 bits, not 32 bytes.
Oh, bits.
4 octets represents 32 bits.
Okay, yeah.
8 plus 8 plus 8 plus 8. Can I answer your question?
Yeah, no, I didn't finish it. Why don't we refer to it as 4? I guess it bits, but I think it's supposed to bytes. I had it backwards. That's just 4 bytes because it's more.
Forget bytes. I shouldn't even brought it up at this point. Forget bytes. Don't get confused about bytes. Okay? 8 bits. 4 times 8 bits. Okay? Remember that. Okay. Let's move on. I need, while I'm talking, Caitlin, would you get that whiteboard looking thing off to the right a little bit more? Just move it off to the right so it's right next to the screen. However, I doubt that's what the camera will help her. All right. And is there a dry erase marker? Yes. Quiet down, please. What? Up to 128. Yep, and that's what we're going to go through here. There is a dry erase marker. Okay, folks. So I'm gonna go away from the slides. Would you turn on the last, Seth? Turn on the last set of lights on the wall. Turn on the last.
There you go.
Okay, so let's talk about how to convert binary to decimal and decimal to binary. Unless you two already know it, you probably should move around. Frank, you're probably going to need to move around to be able to see this. Okay, so we've already said that an IP address, and let's use 208.55.7.3. This is an IP address that's made up of, if I convert this to binary, 4 octets. So 8 bits in each one of these. And so our job is to convert, if we want to go from decimal to binary, our job is to convert 208 to 8 ones and zeros. Here's how we do it. Just memorize this formula. Don't try to understand it right now other than how to do it. Does anyone know this already? How many of you know it? Jessica does. Caitlin does, whether she admits it or not. Aaron probably does. Q is still clueless. Because all he has is visions of his girlfriend again. All right, so here's how you do it. If I want to convert decimal to binary, start out with this 128. You can always remember that. Okay? Have that, and it's 64. Have that, H-A-L-V-E, and it's 32. Have that, 16, 8, 4, 2, 1. How many different numbers do I have? These are still decimal. How many different numbers do I have here? 8. I have 8 different numbers, which represent 8 bits. And so what I'm going to do is I'm going to convert the 208 to bits. All right, so if I want the 208, I'm going to convert the 208 to binary. The first step is, let's take 208 over here and just write it down. First thing I want you to do, does 128 go into 208? Absolutely. So I'll put a 1. Then I'll subtract the 128. Oh my. 0. 10 minus 2 is 8. There's 80. Does 64 divide into 80? Does it? How many times? It's always going to be 1 or 0. 1. So now I take 64 and subtract it. 7 minus 6 is 1. Now here's one for you. Does 32 go into 16? Right? So what do I put there? 0. Does 16 go into 16? How many times? 1. So I subtract 16. Now there's nothing but zeros, so that tells me I've got nothing but zeros here. So the binary conversion of 208 is 1101 0000. 8 bits represented by these placeholders. What? Okay? All right, now, I'll do one more and then you guys are going to start doing it. If I want to convert 55, which is decimal format, to binary, how do I do that? What's the first step? I create my little chart starting with 128 and then divide by 2 each time until I get down to 1. There is no 0. 1, 2, 3, 4, 5, 6, 7, 8. Okay? And I want to convert, so I've already done this one, now I'm going to do this one, 55. So I write that up here. Does 128 go into 55? No. So what do I put here?
0.
Does 64 go into 55?
0.
0. Does 32 go into 55? Once. So I said, what do I do? Subtract it. 3 and 23. Does 16 go into 23?
Yes.
Once. 16. Now I've got 7. Does 8 go into 7? No, so I put a 0. Does 4 go into 7? Once. So I put a 4. I subtract. That's 3. 2 goes into it. Yes, I subtract it. I put a 1. 1 goes into the remainder. Yes? It does. The code, like BASIC, for example, will convert it to 1s and 0s. But all behind the scene, you don't have to worry about it. Just like when you do any kind of object-oriented programming, you don't have to worry about the underlying code. You simply select the objects that you've created earlier or someone else has created for you, put them in the appropriate place, type in the appropriate equations that you need to be able to make it happen, and all the program takes care of all the underlying stuff. If you've ever done a web page using Microsoft Word or something simple like that, you don't have to know HTML to create a web page. You probably want to so you can clean it up, because Word sucks when it comes to converting to HTML. But Word will do that all in the background. Okay? Same thing when you're doing coding. Okay. All right, so we've got 208, we've got 55, so on and so forth. You get the idea, right? Has everyone mastered this?
Yes.
Anyone not know how to do this? Hey, let me ask you this. I started to talk to you about some of the rules about an IP address, so forget this for now. I started talking about some of the rules for an IP address. The first rule is that if I want to send packets between two networks, then I must know, if I want hosts to talk within the same network without a router, then every host within that, every machine within that, as part of its IP address, they all must be on the same network, right? So that first portion of it needs to be the same. In addition to that, every device, just like my phone number in the 574 area code, every host machine must have a unique host address within that network. However, if my host address is the same as in somebody else's network, I don't care, because that's the 312 area code, not the 574 area code. Yes? No, not a port. It's a network address. Port is entirely different. Okay? All right, so everybody with me so far? Some of the other rules, if you think about, if I only have 8 bits to work with in each one of these octets, not in decimal format, if I only have 8 bits to work with, what is the largest number that I could ever have in one of these octets? What is the largest number? Raise your hand. Numbers, names, and hands all over the place. Yes. 255, which means all ones, all the way down. Okay? What is the smallest number that I can have? Yes? 0. But there are a couple rules that are associated with this and how IP works. I can never have a host address that is all zeros. Follow? I'll never have a host address that is all zeros. I can never have a host address that is all ones. You need to memorize these. You need to write them down. You need to whatever. It's in your book, yes. You need to know this. What was that?
Oh, that's the Samsung bar.
Okay, cool. Thank you.
It's not mine.
Hey, it's time to leave. Get out, stay sober, drive safe. I'll see you on Tuesday. Don't forget, you've got a test. Can you shut that off, please?
Push it.